Hey folks, welcome to my channel Number Pen. So there we have the problem on the screen. Let's take a few seconds to read through the problem. A ball is thrown vertically upward from the ground with an initial velocity of 39.2 meters per second. If the only force considered is that attributed to the acceleration due to gravity, find how long will it take for the ball to strike the ground, the speed with which it will strike the ground, and how high will the ball rise, right? So the situation here is I throw up a ball and the ball is thrown with an initial velocity of 39.2 meters per second, right? And what we've been given is as the ball moves up, right, there is a force that is acting on it, and that force is only the gravitational force, right? And what do we mean by the gravitational force? The gravitational force acts in a downward direction, right? And the gravitational force is nothing but it is going to slow down the ball as the ball moves up. And why is that? Because the gravitational force is acting in the reverse direction, right? So as I throw the ball, while the ball has an initial velocity of 39.2 meters per second, the ball loses its velocity, right? And this is something which we've observed, right? I throw a ball up, and obviously the ball reaches a particular height and then it comes back down, right? And at the point when it is going to reverse its direction, its velocity is zero, right? So while the ball has an initial velocity of 39.2 meters per second, I know that my ball is going to lose its velocity at a particular rate. And what do we call that? We call that, I can call it negative acceleration due to gravity, right? I'm going to call it that way. Why is that? Because we have a force acting in the opposite direction. So I have my dv by dt. My dv by dt, when there is a force acting on the ball, when the only force is the gravitational force, slows down the velocity of the ball at the rate of acceleration due to gravity, which is a constant, right? So I have 9.8 meters per second square. So this is the rate at which my velocity changes, and I know that the force is in the reverse direction. So which means I will have to add a minus here, right? So my dv by dt, which is nothing but my deceleration due to gravity, which makes the ball slow down and reach a velocity zero, though it started off with 39.2 meters per second. Now I have an integral calculus problem to solve. I know that my dv by dt is minus 9.8. So I know what is my v. My v is nothing but integral of minus 9.8 times dt, right? Which means my velocity becomes a function of time, 9.8 times t plus c, right? So this is the equation for my velocity. So this is the equation for my velocity as the ball moves up, right? And at some point, the velocity becomes zero. And for me to figure out at what instant the velocity becomes zero, I need to figure out what is my c, right? How do I figure out what is my c here? I use the information which is given to me, which is the only information that I have. Let me highlight it in green. The initial velocity of the ball is 39.2 meters per second, right? And what do we mean by initial velocity of the ball? The initial velocity of the ball is nothing but when t equals 0, right? So when t equals 0, my v equals 39.2, right? And with this, I know that I can solve for my c, right? I know that my C will be 39.2. Why is that? Because I put back t equals 0 in this particular equation that I have, And when t equals 0, my v equals 39.2, which means my c also equals 39.2. So the equation for the velocity at any point of time when the ball is moving in the upward direction is minus 9.8 times t plus c, which is plus 39.2, right? So this is the equation for my velocity. I go to the next line. I know that my ball stops, right, at some point. So we have three questions, right? How long will it take for the ball to strike the ground? So let me figure out at what point the ball reverses its direction, right? So the ball reverses its direction when v equals 0, right? Remember, folks, in our earlier substitution, we substituted t equal to 0 when we knew that the ball had an initial velocity. Now I put my v equals 0 because I want to figure out what is that instant when the ball changes direction, right? So when v equals 0, my t becomes equal to 39.2 divided by 9.8, which is nothing but 4 seconds, right? So at the end of 4 seconds, I know that my ball changes direction. The ball takes 4 seconds to reach a certain height and then falls back through the same height, right? Now, the next step, what we're going to do is figure out what is the distance the ball traveled in these 4 seconds, right? And I'm again going to use integral calculus to solve this particular problem. So I know my distance traveled in a small time dt is nothing but ds is nothing but v dt, right? And I know that my v is expressed as a function of time, right? Which is from the previous equation minus 9.8 t plus 39.2, right? So let me copy that. I hope you folks are with me. Rate of change of distance with respect to time is nothing but your velocity, right? So ds by dt, where s is the distance, is nothing but your velocity, right? So what is that infinitesimally small distance the ball travels in a time dt, which is also infinitesimally small time, right? And why are we doing this? We are taking the help of integral calculus to solve this problem because the ball's velocity is a function of time and the ball is not moving with a constant velocity, right? And therefore we figure out what is that infinitesimal distance that the ball moves in that infinitesimal time dt, right? So that is where this expression what you have ds equals vdt is what you see on your screen, right? Again, looks like we can beautifully solve this problem using integral calculus because if my ds is equal to this, then my s is nothing but integral of this particular expression, right? And this is something very familiar to me from my earlier videos. I can solve for my s, right? So I'm going to write my s as I apply the sum rule of integral, my minus 9.8 remains as it is. And then I have integral of t dt, which is nothing but t square by 2. So let me write that. T square by 2 is, and then I have plus 39.2 times integral of dt, which is nothing but a t, right? And then I have my constant, which is very important. So I have minus 9.8 t square by 2 plus 39.2 t plus c. I know that I can do a little bit of simplification and I can express my answer as minus 4.9 times t square because my 9.8 divided by 2 is 4.9 plus 39.2 times t plus c, right? So this is the equation for my distance traveled, right? I will have to figure out at the end of 4 seconds what is the distance traveled by the ball, right? Now, at the end of 4 seconds, the distance traveled by the ball can be very quickly arrived at by just making a simple substitution t equals 4 in this particular equation what I have on the screen. But then the challenge is I do not know what is my constant c. And like we solved for c in the velocity equation, we will have to solve for c in the distance equation as well, right? So I know that at t equals 0, my distance traveled by the ball is 0, right? So at t equals 0, my s equals 0, therefore my c also equals 0, right? And therefore, I know what is my distance traveled by the ball at any point of time when it moves upward, right? So I have my s equal to, since my c is 0, my equation is minus 4.9 t squared plus 39.2 t, right? So at t equals 4 seconds, which is when the ball reverses its direction, I have minus 4.9 into t squared, which is 16, plus 39.2 into t, which is 4, right? Let's write it like this: 78.4. And my distance is expressed in meters, so I get 78.4 meters. So in 4 seconds, I have traveled, as in the ball has traveled 78.4 meters before it hits the ground, right? So let's go back to the question and understand what all have we been asked, right? So how long will it take for the ball to strike the ground? Do we have the answer for this question? No, not yet, right? Second question is speed with which the ball will strike the ground. We've been asked to figure out once the ball hits the ground, right? What is the speed at which it will hit the ground? Do we have the answer for this? No. And the third question is how high will the ball rise? Do we have the answer for this? The answer is yes, because we just worked out that it is 78.4 meters, right? Now we will have to figure out two other parts to this question, right? What are those? How long will it take for the ball to strike the ground? Now the ball has taken 4 seconds to go up, and we'll have to figure out how much time does it take to come down, right? Which means I have the distance through which the ball must travel. I have the initial velocity of the ball when it is about to change direction. And what is that velocity? That velocity is now 0, right? So I can use the same approach which I used to solve the problem when the ball was moving up. But this time I want you to understand that when the ball comes down, right, there is a force acting in the direction of the ball itself, right? And this time my dv by dt is not a minus 9.8, it is a plus 9.8. And why is that? Because my dv by dt is acting in direction of the ball itself, right? So, which is again the only force is my acceleration due to gravity. I can solve the problem using integral calculus. I know that my v equals 9.8 times t plus c, right? So this is the equation for the velocity of the ball when the ball is coming in the reverse direction, which means it's going to hit the ground back, right? So my v equals 9.8 times t plus c, right? Like we did in our earlier problem, I will have to figure out my constant c. And what is my constant c? I know that my ball's initial velocity this time is 0. Why is that? Because I've thrown the ball with an initial velocity. The ball loses its velocity due to deceleration due to gravity. And then at some point, it hits 0, the velocity of the ball. And that's my initial velocity when the ball is going to come in the reverse direction to strike the ground, right? So I have my v equals 0 at t equals 0, which means my c can be solved, and which is nothing but it is equal to 0, right? So my v post solving for c is plus 9.8t, right? So this is the equation for v. And so what is that we've been asked to find, folks? So I will have to figure out how much time, you know, the ball takes to hit the ground, right? So I know the distance the ball has to travel because I just figured it out, from my earlier steps that we worked out, that this distance is 78.4 meters, right? So I know that the ball has to travel the same distance, and we are going to apply something very similar to what we did earlier. So my ds again is equal to v dt, right? Which means my s equal to integral of v dt. And I know what is my v because my v is a function of time. So which is nothing but 9.8 times t. So I'm going to write that out for you, dt. And this is something which I'm quite familiar with, which is nothing but 9.8 times integral of t dt, which is nothing but 4.9 times t square plus c, where c is my constant, right? So I know that my s in terms of t is nothing but 4.9 times t square plus c, right? And to figure out what is my c, I need to know. Now I know that I have my s in terms of t, but then I have a constant c as well, right? So how do I figure out what is my constant c? So this is the equation for the distance traveled by the ball, right, in its reverse direction. So at t equals 0, my s will be equal to 0. Why is that? Because the ball has not moved at all, right? The ball, at the point of time when it changes direction, it has not moved through any distance, right? So at t equals 0, my s equals 0, which means my c equal to 0, right? Right? And therefore, I put back my c equal to 0 in this particular equation. I get my distance traveled by the ball in its reverse direction. The equation for that is nothing but 4.9 t square, right? I know that the ball has to travel the same distance that it traveled in its upward journey, right? And now that the ball is taking a reverse direction, it has to come through the same height before it strikes the ground, right? And that height is something that we already know, which is nothing but 78.4. So I know what is the time it's going to take for the ball to travel through the same distance in its reverse direction, right? So my S equals 78.4, and I know that my T is nothing but square root of 78.4 divided by 4.9, which is nothing but a square root of 16, which is nothing but 4, right? So that's the answer we get. So the ball takes 4 seconds to strike the ground back, right? So the ball has moved upwards 4 seconds, and then it takes 4 seconds for the ball to come back. So let's go back to the question and see if we have all the answers. How long will it take for the ball to strike the ground, which is our first question, right? So let me highlight it and say yellow color. I know that the ball went through 4 seconds, and we just calculated the time taken by the ball to come back in its reverse journey before it strikes the ground. That's another 4 seconds, right? So how long will it take the ball? Time taken by the ball to strike the ground, 4 seconds in the upward journey and 4 seconds in the downward journey, which means my answer is 4 plus 4, which is 8 seconds, right? That's the answer for question one. I hope you folks are with me. Let's go to question two. Speed at which it will strike the ground. Do we have the answer for this yet? The answer is no, but then we have the equation which will help us solve this particular question, right? I'm referring to this equation, v equals 9.8 t. This is the equation for the velocity of the ball in its reverse direction once the ball hits a height, and then it's making a reverse direction, right? It's going to strike back the ground. I know that at 4 seconds, at the end of 4 seconds, when it strikes the ground, right? Because that's the time it takes to strike the ground post reaching a height, while the total time taken is 8 seconds. But the equation that we have here on our screen is for the velocity of the ball after it reaches a particular height. And we just calculated that it falls through to the ground in 4 seconds, which means that my velocity when it hits the ground is 9.8 times t, which is nothing but 39.2 meters per second, right? So that's the answer for my second part. Let's write it down. Velocity when the ball strikes the ground is 39.2 meters per second. I have the answer for the second question as well. Now let's go to the final part of the problem. And this is something which we solved earlier. How high will the ball rise? I know that the ball rises through 78.4 meters before it takes a journey back to the ground, right? There we are. And the final answer to this particular problem is what I have written down. So let me highlight it in pink. So, again, a very interesting problem that helps us understand the simple applications of integral calculus. I know that for those of you who are looking through this problem or this type of problem for the first time, it can be quite complicated because you need to understand a little bit of physics as well that goes around, solving these problems. But if you have a problem in understanding this problem, please do write in your comments and I'll be happy to connect back with you through my YouTube channel and help you understand this problem better. I hope you found my content useful. Please do subscribe to my channel and support.